Okay, so what do we mean by distinguishable permutations? Distinguishable permutations are what we want to count when we have a group of things and some of them are exactly alike. So say here I've got a blue block and two red blocks, and I want to say how many ways can I arrange them in a row. Okay, well, if the two red blocks look exactly alike, now I'm giving them numbers right now just so you can tell which one's which. But blue, red, red, where the first red is red number 1, the second one's red number 2, looks exactly like blue, red, red when the second red block is first and the first red block is second. So these two permutations look exactly alike. I don't want to count them twice. So if I have one blue block and two red blocks, I don't want to count these two as different. I don't want to count these two as different. They look exactly alike, even though the red block here is red number 1 and this is red number 2. I'm just putting those numbers there so that you know the two blocks are different. They're not different, but just so you can see what I'm trying to say is that it doesn't matter which one of those comes first or second. I don't want to count them as different if they look the same. So if this one looks this one looks just like this one, I don't want to count those twice. I only want to count them once. So whenever I have items that are alike, and I want to find out the number of distinguishable linear permutations, what I have to do is I have to divide out the number of ways to arrange those things that are alike. So for example, here I've got the blue, red, red, blue, red, red. I don't want to count this twice. I only want to count it once. So I'm going to divide by 2 so that it's only counted once. I'm dividing by the number of ways to arrange the two red blocks. There are 2 ways to arrange the 2 red blocks. So if I divide out at 2, then it only counts each one of those one time instead of twice. So when I'm counting distinguishable permutations, linear permutations, I will take n factorial, that's the total number of things I have, and then I'll divide out the number of ways to arrange any of the things that are alike. So if I have a things that are alike, I'll divide by a factorial. If I have A of one kind of thing, and B of another kind of thing, and C of another kind of thing that all look alike, there's a bunch of these things look alike, these things look alike, and these things look alike, I'll divide out the ways to arrange those things, so that for each way to arrange them, you only count it once. So, an example, Spencer has 10 marbles, 3 are red, 3 are blue, and 4 are green. How many distinguishable permutations of the 10 marbles can he form? All right, so I could arrange the marbles in 10 factorial ways. There's 10 of them. But a lot of those are going to look alike because there are 3 red, 3 blue, and 4 green. So what I want to do is divide by the number of ways to arrange the red marbles, the number of ways to arrange the blue marbles, and the number of ways to arrange the green marbles, so that for the ways to arrange, anytime I have all the ways to arrange the red marbles, it'll be over 3 factorial and it'll only be counted once. So this would be 10 times 9 times 8 times 7 times 6. It's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 3 times 2 times 4 times 3 times 2. And you can do a lot of canceling here. You can cancel a 9 with the 3 and the 3. You can cancel an 8 with the 3 of the 2's. You can cancel a 4. You can cancel a 3. And then that's all gone. So you've just got 10 times 7 is 70, times 6 is 420. Times 5 is something. Anyway, you can figure that out. Right, here's a calculator. So you'd have 10 times 7 times 6 times 5 times 2. So there'd only be 4,200 ways that you could arrange those marbles distinguishably so that they actually look like different arrangements. Okay. How many distinguishable permutations can be formed from the letters in the word nonsense? Okay, well, there are 1, 2, 3, 4, 5, 6, 7, 8 letters. So there are 8 factorial ways to arrange those letters, but some of them are going to look alike because there are 1, 2, 3 n's. So I need to divide out the ways to arrange the n's. There's one O, so that's okay. There are two S's, so I should divide out the ways to arrange the S's. That would be 2 factorial. And there are two E's, so I need to divide out the ways to arrange the E's. So everything else is different. So if I were to multiply all that out, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 2 times 2. 8 goes away, 3 goes away, 7 times 6 times 5 times 4 times 2 would be 1680 ways. Okay? How many distinguishable 7-digit numbers can be formed from these digits? And just arranging them. There are 1, 2, 3, 4, 5, 6, 7 digits, so 7 factorial ways to arrange them. But there are 1, 2, 3, 4 2's, so I need to divide out how many ways to arrange those 4 things. And there are 2 4's, so I need to divide out how many ways to arrange those 2 things, which is 2 factorial. And that's it. So that would be 7 factorial divided by 4 factorial times 2, which would be 105 ways. So that's distinguishable permutations. You just count the number of things that arrange all those, and then divide out the ways to arrange the things that are the same. There's 4 2's, so we divide it by 4 factorial, 2 4's, we divide it by 2 factorial, and there's 1 7, so it doesn't have any others.